Very good. So let me give you a tour of the Design Studio tool, which is used to compose the basic building blocks of a machine learning application. So here is a Design Studio, and let me take you through what are the various parts of the studio. These are the models that you have already onboarded, and Guy and Paul shared you how to onboard the models. So you see this, we have categorized the models in different buckets. So right now we have models which does prediction, classification, regression, and some other category. Then here you will see solutions that are composed and are made public. So far, no solution is public. Then underneath is the data transformation tools, and this is used for constructing the directed acyclic graph. I will explain that very soon. Then we have the data ingestion mechanisms, which we call as data brokers. These data brokers allow you to ingest the data from data lakes, from databases, or even sequential CSV files. Then on the right-hand side are the properties and the matching models that I will explain right now. So let me onboard. Let me show you a pre-composed model, a composite model. What I'm going to show you here. This is a composite solution which consists of data ingestion model, and then I'm using the ingested data and feeding it to 3 different fraud detection algorithms. I'm using support vector machines, a linear regression, and a third one, and then all of them are producing their own prediction. And then I'm taking the majority of it, the majority answer later on. But before I go into it, let me show you. When I click on the model, I'll see the details of the model. When I click on so each model has 2 ports, input port and an output port. Essentially, each model is a microservice, right? And a microservice exposes an interface, predict, classify, do X, Y, Z, whatever it is. And this is, so here, when I hover over the input port, I say this is a microservice which performs a classification operation, and it takes a certain input and it spits out a certain output. When I click on the input, I can see the message signature. This is the message that is accepted by the RPC, and the message that is spitted out by this thing. Then when I click on the port itself, I can see what are the other models that I can compose it with, matching models. So what this guy is saying is that at this input port, I can connect the output port of these set of models. So these are the models that can be syntactically composed at that particular port that I have clicked. However, whether that makes sense to connect them or not is the semantics part. That is what the modeler will decide. Now, let me also show you this concept of a splitter and equivalent. So, okay, let me complete the story. So here I have ingested the data, and I'm providing the same data, in this case, to 3 different models. They are producing their own individual prediction. I'm combining the results and feeding it to a fraud, a majority vote model that is going to say whether the output will be 1 or a 0, depending upon the majority vote that I have collected from the previous models. So now, what are these splitters and collators? As I told you, each model exposes an RPC, right? It's an RPC-based interface. So each model accepts a message and spits out a message. A message is a set of parameters. So the models may want all the parameters that are produced by this ingestion model, or these models may want only part of the data, not the entire data. This splitter can, this splitter supports both copy-based splitting and parameter-based splitting. In this case, in this example, we are providing all the data to the three models that will perform the prediction. Similarly, in the case of a collator, here I'm collating the data or collating the prediction output of the previous three models. And therefore, I'll show you that here I have a map function where I'm mapping the output of the previous models to the input of the destination or the target model here. I'm not going to go into the details of it. By the way, in the afternoon during lunch session, we will have a detailed demo for those who are interested behind these screens. All right, so now once I have composed these models and performed the splitter and collator mapping, I can then save the model. I can then save the model. I save the model and then I perform. Then I can validate the model. So what is validation? As part of validation, we make sure that the interfaces match, that the splitter and collation function has been done properly. And once we validate the model, you will notice the deploy button is inactive. You cannot deploy a solution which is not validated, right? So this is still inactive. Now let me validate the solution. And once I have validated the solution, I got a valid composite solution. Now you can see I have a deploy button, which is activated. So now I can go and deploy to the target clouds. In the Athena release, we are supporting deployment to Microsoft Azure and to another Kubernetes too. But in future releases, we are planning to other target cloud platforms. So once I have composed the model, validated the model, generated the blueprint of the model, now I'm ready to deploy this composite solution. And again, the composite solution consists of both the ML models and the non-ML data ingestion models. So with that, I will go and deploy to the Microsoft Azure, and from here, the deployment, I will have to provide all the parameters for deployment, which I'm not going to do the demo right now. But so this is the from composition to validation to blueprint generation, ultimately to deployment. That's the message I wanted to come across. But if anybody has more questions, I will be behind the screen during the lunch hour to take more questions. Thank you very much for your ear. Thank you. I have now to summarize everything together, we have Anwar who will summarize and bring all things together. And so to Anwar now. I'll stop here.